Before Docker, deploying an app meant one thing: hope.
Hope the server had the right OS, hope the right versions were installed, and hope nothing broke. There is a reason Docker shows up in almost every backend job description today. Because works on my machine is not a deploy strategy. Docker exists to fix this. In this video, I will show you what Docker actually is, why developers use it, and the only commands you really need. Modern apps depends on a lot of things. Language versions, system libraries, environment variables, external services. When those don't match, things break. Docker gives us one simple idea: control the environment, and you control the behavior. Here is the simplest way to think about Docker. Normally, your app runs directly on your machine. This is just a tiny Python app with a FastAPI web server. Right now, this app is running directly on my machine, and that's the problem. If I send this code to someone else, there is no guarantee it behaves the same. Other guy may have another version of Python or FastAPI. Docker adds a thin isolation layer. Your app still runs as a process, but now it runs inside a container. That container has its own file system, own dependencies, and own environment variables. But it still uses the host OS kernel.
That's why containers are fast. So when you're shipping the container, you're not just shipping the code, you're shipping the exact environment your app expects.
If it runs in a Docker container, it will run the same on your laptop, server, or cloud. By the way, Docker is not a virtual machine. Virtual machines simulate hardware and run a full guest OS. Containers don't do that. They share a kernel, which makes them lightweight and fast, and you can run dozens of containers where you would struggle to run a few VMs. To keep things simple, let's quickly cover the core concepts. An image is a blueprint, basically a recipe. A container is a running image. A Docker file is just instructions for building an image. Docker Hub is a GitHub but for Docker images.
Don't worry about memorizing this, let's run something.
First, let's make sure Docker is installed. If you see a version number, you're good to go. Otherwise, just visit docker.com and download Docker desktop application. Now let's run a real service. This command might look a bit long, so let me break it down real quick. Docker run starts a container. Flag D runs it in the background. Flag name my_nginx, give it a readable name. Flag P maps port 8080 on my laptop to port 80 inside the container. And nginx alpine is the image, a lightweight nginx server. What just happened? Docker didn't find the image locally, downloaded it from Docker Hub, created a container, and started it. Let's confirm that it's actually running. Docker PS shows all running containers. Here you can see the image, the status, the ports, and the name. Now let's see if it works. I open localhost 8080 and there it is. Nginx is running. I didn't install Nginx on my machine, I just run a container. Now let's take a look inside the container. This command runs a shell inside a running container. And now watch this. This is not my machine. This is a container. It has its own file system, own processes, and own environment. Let's exit the container. Every container produces logs. Docker logs shows that output. This is incredibly useful for debugging. Now let's stop the container. Docker sends a seek_term signal. The container shuts down gracefully. After that, we can remove it.
In the next video we will build our Docker image from scratch. We will write Dockerfile and Dockerize a real application. Hope you enjoy. See you next time.